Hey everyone, we are here with Diwaker Gupta, head of engineering at Blockstack, and Silvio Micali, founder of Algorand, and they'll be doing a fireside chat, and I'll let them take it from here. Once they start talking, can you guys confirm in the chat that you can hear them?
I can hear you feebly, but I hear Diwaker extremely well.
All right, well, thank you, Shinju, and welcome everyone. If everyone can hear us, someone just put in a word in the chat. I'll just wait to get a confirmation before we move on. Maybe someone from PVC. Okay, there we go. All right, I think folks can hear
Hey,
us. Well, before we jump in, I just wanted to take a quick second to thank Silvio for being with us. For those who are not aware, Silvio is a Turing Award winner, really a legend in our field. It's a true pleasure and honor to have you and to have this conversation just around, I'm hoping we can keep it very free-flowing, informal, and casual and take questions. I'm looking forward to it. Very quickly about myself, I'm the head of engineering at Blockstack PBC. And before that, I spent a decade in Silicon Valley working in a number of different companies, spent 4 years at Dropbox. Before that, I did a PhD in computer science from UCSD, but all of my research was around systems and networking. And so in a way, coming to crypto has been interesting because parts of what we do and what we work on are familiar, but then there is so much that is new to me. So it's been a fascinating sort of experience just getting to see this industry from the outset. So with that, welcome Silvio.
hey, thank you very much, Diwaker. It's a pleasure to share this evening with you and your audience, and it's a pleasure even more to have Algorand collaborate with Blockstack. We really are enjoying it.
Absolutely. So with that, like maybe we can just dive in. Would love to hear your perspective on, why does the world need yet another smart contract programming languages? Computer scientists are infamous for like everyone wanting to build their own programming languages, and we don't have no shortage of programming languages in the non-crypto world. So in the crypto world, like how do you think about programming languages and that ecosystem?
So, well, first of all, somehow smart contracts ought to be really a golden opportunity, right, for VMs. And you'd think that after so many years, we would have ironed out all the problems, but we haven't. And so I really think that we need, a lot of principles to be applied that somehow they're not being applied or not at least applied together. So we want to have a decidable language to minimize, errors of all kinds. We want to be able to compute, easily and quite accurately what the cost of running a smart contract is going to be. We want to have a strongly typed language, and the list goes on. So you'd say, why has not been solved? I don't know, but you know what? Very often I stop asking. The important thing is that you and I mean, our teams recognize that these are problems, and we go after to solve them.
Yeah, absolutely. And just to kind of echo on that, from my perspective, programming languages or any of these systems, they exist to solve certain problems for our users and developers. And there's hardly ever going to be like a single solution or a single system or a single platform that solves all problems for everyone equally well. And so to me, it's like less about why do we need a new programming language and more about, are there existing use cases that are not being served well by existing solutions, and is there space for something new to address those use cases better? So if you look at the design space for smart contract programming languages, Solidity has made some set of design choices that are maybe serving some set of use cases well. But I think we believe, and Algorand believes, that there are many use cases and many other use cases that will potentially be better served by a language that makes different set of choices. Whether it's decidability or predictability of execution costs, or optimizing for static analysis, or even I think just philosophically speaking, optimizing for safety over convenience. Let's say where we are kind of making the choice that maybe a programming language that's a little bit harder to learn, but also harder to make mistakes in, is not such a bad idea compared to a programming language that is super easy to learn, but also easy to make mistakes in.
Amen. So I mean that it's very hard to recover a mistake, and I think to invest a little bit more beforehand is a good thing. To your point, I agree with you that the space is really immense in the blockchain space, and we welcome a difference of opinion. But whenever there are actually fundamentally shared philosophies, like in our case for the VM language, I think we should cooperate. And all too much we see is that each one want to have their own road. I mean, I think is nuts. So blockchain is a very sophisticated product and does require a lot of effort, and many eyes and many hands are working on it. So to reinvent the wheel doesn't seem to be a good idea to me when there is so much novelty and so many other problems to solve.
Thanks. And you mentioned a few of these things already, but just to sort of catch everyone up, maybe let's talk a little bit about what Clarity is, what makes it uniquely different, and what sort of features does it provide. So for folks who are not familiar with Clarity yet, you can go to clarity-lang.org, and you can find a lot more information there. But Clarity is a functional language model after Lisp. Smart contract language, currently supported. We have an implementation on Blockstack, and we're collaborating with Algorand. Algorand is working on an implementation of their blockchain, and we'll hear more from Silvio on sort of where things are. But some of the interesting features in Clarity, it's obviously a functional language, so it's not imperative or procedural. So there is a little bit of potentially a learning curve for some people. But then the benefit is that it is very easy to parse, very easy to construct abstract syntax tree, and a lot of research that we can lean into for doing static analysis and really create predictability around program execution. I think Silvio mentioned this already earlier, but Clarity is a decidable language. And the trade-off there is that it's by design not Turing complete, meaning that there will be certain constructs that you will be unable to express. So we're losing maybe something in expressivity, but we are gaining something in safety. So in particular, you can't do recursion in Clarity, and certain forms of dynamic dispatch are also not allowed. And then the final another interesting feature, at least on the Blockstack implementation, is that Clarity is an interpreted language, so we don't have a compiler. And the thinking there is that we want to minimize the delta between what the programmer's intention is. So you're conveying your intent through some code, and what actually gets executed on the blockchain. That delta should be as small as possible, so that creates a minimal surface area for bugs. As an end user, it should be very easy and obvious for you to figure out what is the smart contract that you just committed to interact with. And there are some interesting features for users as well that I'll talk about in a second. But turning over to you, Silvio, like for you, like what are the things about Clarity that stood out in terms of I think for me, like one breakthrough moment was in the beginning when we were speaking to the team at Algorand. We were talking about sort of design philosophies and ideas, and literally every single thing that both the teams mentioned, there was a mind meld of ideas essentially.
Correct. I already mentioned the principles before, having Turing disability, so I'm making it very, very hard to introduce errors. You really need to work now much harder to make a wrong smart contract. We mentioned about assessing cost beforehand, and a few other things. But besides this a philosophy, we have also another thing that we really appreciated the fact that you guys are not just a prototype, right? But you are essentially a product ready, an industry level software, and because if we don't want to reinvent the wheel, at least we want to have a wheel that works already quite well. And the second thing actually that we appreciated is actually the simplicity that is at the aim of Clarity. Because I really believe that simplicity is the ultimate sophistications, and having unnecessary and over complex frills is not a benefit; is an encumbrance. So for all these things, we did actually a thorough literature review to see if we don't want to reinvent the wheel when, and I think that that's why you guys came on top.
So maybe you can tell us a little bit about, Algorand already has a smart contracting language called Teal. So maybe you can tell the audience here a little bit about where does Clarity fit into the Algorand platform, and when and what this integration might look like.
Great. So we have we share a common language that we want to improve and make it as perfect as we can make it. And but we have, as it should be, different approaches to smart contracts. The Algorand approach is that we separated smart contracts into two classes. One class is layer 1, and the second class is layer 2. So layer 1 contracts somehow are executed at the very consensus level, so without slowing down the block. They are executed really at the most secure level of a blockchain. And they have a language called the Teal, which is again a very simple language. Think of it like an assembly language with some 30 instructions, and to be executed again one after the other. And believe it or not, however, these 30 instructions are being executed to satisfy a bunch of problems. To satisfy a bunch of requirements. First, that it's extremely fast. We can execute 1,000 layer 1 smart contracts invocations per second. That is very good. And the second one, we can satisfy somehow some large portion. Let me go on a limb and say 90% of the reasons for people who want to do smart contracts. And in a very secure way, and so efficient and securely as an ordinary payment. And that is no small accomplishment. So what can we do? So, well, we can actually do things like, atomic swaps. Say you and I, each one of us has his own asset, but I like your asset, you like mine. Who goes first, right? We want to be able to exchange them simultaneously without the intervention of a third party. We want to do a loan with a collateral. So we may want to run an entire auction. We want to create, a new assets and token, a layer 1. And by the way, this is one of the good things is that a layer 1, if you create an asset and I create an asset, the assets are really necessarily identical. When we know really what the assets mean. When we create assets a layer 2, we may think that is this, I know what you're doing and you know what I'm doing, but the imperceptible difference may exist that prevents these smart contracts somehow to interoperate. That said, not all needs for smart contracts can be satisfied at layer 1, and for everything else there is a layer 2. And when we go to a layer 2, we need a language, and that's when we decided to cooperate on the language. Our layer 2 contracts are quite unique. We have a very different approach, but we are very happy to interoperate with us at the language because we want to minimize really language in the sense of communicating with another blockchain. We really incorporate. We want to have really a common language, metaphorically and technically speaking, to be able to interoperate.
Wonderful. I think we have maybe 5 more minutes left, and then we'll have some time for question and answers as well. So another thing, a question that I've heard often is sort of some variant of, if I have a Clarity smart contract, will I be able to just run it as is on Algorand and on Blockstack? And will there be kind of differences? What does it actually mean to have this common language? Is it going to be compatible, to the sort of exact implementation detail? And so maybe Silvio, you can share sort of Algorand's perspective on what is the Clarity integration going to look like, and when can people expect to be able to run Clarity smart contracts on Algorand, and then I can talk about Blockstack.
All right, there is a lot to unpack, and perhaps we can go one at a time. When I think next year you should be able to run Clarity on Algorand, right? And so that is the good news. the language may be the same, but the look and feel of the contracts are going to be different. And so you guys execute the contract somehow on the block. We execute them off chain. So somehow you call you should be able to call the contract on chain, and then a separate committee is in an Algorand fashion by magically convene in a secure way to execute the contract, and our blocks continue. When they are ready to return the answer, they are returned. And by the way, and this particular differences between us make sure that Clarity is not, even though it is really the best base to move forward from, is not going to be the end product. So you and I should collaborate to introduce in Clarity enough features so to take care of this unique need of ours. And so, for instance, because we are going to execute this contract speculatively, essentially off-chain, so we may want, when we start, doing a cost analysis of the contract, to have not just a single number that represents the cost, but a formula that can depend on various parameters later. And so, and for doing this, we need to somehow enhance and enrich Clarity a little bit. Or we have some technical things, but when we have variables with different domains, and we want to be able to address one of them rather than all of them at the same time. But by the way, once Clarity has this flexibility that satisfy our needs, they also satisfy your needs too. And so I think we are going to have a better language as a result.
Yeah, absolutely. And for folks who are not aware, we are really thinking of Clarity as almost an independent project that Blockstack and Algorand are contributing to. But over time, we certainly hope that other people, other projects that resonate with the ideas behind Clarity will join forces and then bring their own ideas and their own implementations on the board. So we have a pretty healthy set of sort of issues and a feature requests that are coming in from at least our community, and I hope the same will happen on the Algorand side as well. One thing that we've been talking about recently quite a bit, and I think Algorand's layer 1 versus layer 2 architecture maybe simplifies this. But I'm curious, Silvio, what are your thoughts on programming language evolution in blockchains? Because blockchains are notoriously hard to evolve purely from a software development perspective. And so in that context, like, how do you think about language evolution over time?
So, Diwaker, this is not a question of programming language. The entire blockchain protocol, the entire consensus protocol, the entire blockchain project has to be able to evolve. So when we launched Algorand, we had this right away fair and square in front of us. Nothing in life, whatever does not evolve, either is dead or is surpassed and becomes subjugated by other species who didn't lose the ability of the will to evolve. Okay, so if we don't evolve, we fall by the sidelines, and that is not good. So we make sure that Algorand actually was allowed for from the very beginning, from the very inception, to have a protocol that evolves. And in fact, we launched with our basic consensus protocol. Last fall, we launched the first, layer 1 tranche, which is called the stateless TEAL. And this August, we launched the second stateful TEAL layer 1 smart contract. And we're going to launch using Clarity what we call the smart square contracts, our layer 2 version contracts. And we are going to continue to evolve. If you are tired of evolving, I mean, you are tired of life. Evolving has to be in our DNA. And a blockchain is used by society, by real people, and we want to be able. I believe our philosophies are really not aligned here to serve not only the immediate needs of our community, but also the future needs for our community. And for this, the entire blockchain, not the programming language alone, should be able to evolve.
Yeah, absolutely. I couldn't agree more. And in fact, it was great to see we had a proposal come in from one of our community members that has since multiple people have jumped on it to sort of refine it further. And essentially, it's a proposal to introduce new Clarity features without requiring a hard fork of a blockchain. And so there's some clever ways in which you can add new capability, maybe have an implementation that's not super optimized, and then over time allow optimized implementations or more native implementations to kind of slide in underneath once sort of adoption kicks in. So some really interesting ideas that are people are experimenting with.
At Algorand, we hate forks. Not only the hard forks when, but also the soft forks. We try to avoid it because we want every block that we produce to stay on the blockchain forever without forks. So we are total. I totally approve. I'm with you, Diwaker.
All right, we have about 8 minutes left. Folks, if you have any questions, please put them in this Ask a Question panel, and I will read them out. So far, we only have one question. Doesn't seem as super directly related, but I'll ask it anyways. Question is, would Algorand ever publish third-party security audits of their code base, release process, and smart contract language?
Sorry, one more time, more slowly. Will Algorand ever publish what?
Third-party security audits of your code base.
I'm surprised if you already don't. So our intention is to publish. We don't have any notion of keeping anything in the dark. So I believe certainly we have let alone tested, but actually let alone having third parties verify as appropriate to have even the formal methods used to prove the correctness of what we are doing. And we love transparency, and we should make them always available. And as far as I know, always is available.
Yeah. So I guess like John who asked the question, feel free to look it up. Should be available. If not, you can follow up with the Algorand folks. Since there's no other question here, maybe I'll use this as an interesting tangent. Last week or 2 weeks, the crypto community was sort of being enamored by Yam Finance. I don't know, Silvio, if you heard about this, but there was this new product that was launched. It was built on top of the Ethereum blockchain, set of smart contracts. They were not audited, and a lot of capital was poured into the project. I believe it was maybe in the tune of a few $100 million. And then later on, a bug was discovered. I think a lot of the capital was originally lost. Some of it was recovered. I think some of it is permanently lost. But all that to say, at least I find that in the crypto community, to me, there seems to be sort of this notion that just because you audit something, it becomes secure, and if you haven't audited something, it maybe automatically is insecure. I certainly have thoughts on that, but wanted to hear kind of your view on, how can programming languages, help programmers feel more confident in what they are writing, with or without the need for some external audit. Because at the end of the day, if something goes wrong, you are the one, as a programmer, you're the one who's accountable and who's on the line, like not the person who did the audit.
No, I agree. By the way, as humans, we should figure it out that we make errors, okay? So that goes with the territory. If we are some angelic creatures somewhere else, good luck, but we are not, okay? So, but what we should do is, we should do our best to minimize error, okay? So certainly the person who writes the smart contract should try to make sure that it looks twice, and it's good for them to have third parties look at it. But we, as a blockchain, so providing a platform for people who write smart contracts, we should do even more. And we are doing even more. So we are collaborating to having a language that will prevent, as much as is preventable, human error from occurring. So we are going to have making things easy. We for sure will having our software audited, and even though some of our customers may elect not to, we for sure we are going to have formal methods designed, and we are doing everything we can to make a very strong and secure effort. And by the way, to the point of transparency, our ultimate thing is really to make it an open source so that everybody can see what we are doing. So in the battle of errors, we cannot prevent errors ever from our customer to make, but certainly we are doing the best to make sure this does not happen on our watch or for a fault of not putting enough effort ourselves.
Absolutely. I want to take the second question here. It's asking, how do you envision Clarity working with oracles? Great question, Tarun. So just from a pure language perspective, there are still some language features that we are working on that would enable, and you could consider some of these features to be essentially blockers to working with Oracle. So specifically, today Clarity does not have any native cryptographic primitives built in. So for example, if you want to do recoverable signature verification through a native Clarity function, today that's not available. Presumably for any kind of Oracle implementation, or more generally, any interaction where you want to take some off-chain state and represent it in a provably secure manner on chain, you want to do some cryptographic verification. So you want those primitives. So that's one key feature that's currently missing, and we, at least on the Blockstack side, we have plans for that. Sorry, go ahead, Silvio.
I'm saying you're right. So, ladies and gentlemen, we should accept that this is a journey. Okay. So our collaboration is a journey, and we are starting this journey. And so, but we have to remember, we have to start from somewhere. So the notion to have that we are going to be somehow born adult, we all know that we are infants, we are kids, we are teenagers, we are adults, and so on and so forth. And so we launched right away, for instance, speaking for ourselves, our consensus protocol to make sure that people could really see and see that we could produce a block in a few seconds with finality and at scale. And for us, we wanted to do it. So did we wait to have our layer one smart contracts right away? No, I'm to say we are going to handle simpler transaction, simple payments. But yet to start with one, people look at you, you add another one, and one step leads to the other. So I really believe that the perfection is the enemy of the good. What we should aim for perfection is to put as much effort as possible to deliver safely for ourselves and our customers what is that we deploy. But deployment has to be a road, and we cannot solve all the problems, Oracle included. Yes, we should have Oracle soon, but I will not put it as a condition. Otherwise, what's the point of launching Clarity? I don't believe that actually there is a lot that we can learn, a lot of benefit we can give with the Clarity as it is, and of course we will improve it later, provided that we have protocols like ours that actually are engineered from the get-go to enable evolution. To me, the ability to evolve is the most fundamental criterion, not only in blockchains, but in life. So the notion that what is written forever, then that's a bad recipe. Who wants to start a journey with a fixed course, iceberg, no iceberg, typhoon, no typhoon? You keep the course that you decided originally. This is impossible. But if we put in our DNA of a blockchain ability to evolve, we'll go far and we'll go safe.
Wonderful. Well, we are at 8 o'clock. I don't know if you have more time as well or not. So if Shinju, if you're around, if you can chime in.
Yes. So we need to transition to the next talk, if that's okay.
All right. Well, thanks.
All right.
Thank you, Silvio, and
Diwaker,
having you.
Best of luck to you guys. We enjoy working with you, and greetings to Manib and onward.
Onward, indeed. Thanks, everyone, for joining in. Take care.
Thanks.